Well, let's figure out how to build a house without really building the house. So, the first term I want to introduce here is frame. So, the walls of your house are not solid wood. There's actually empty spaces in between the pieces of wood. And so, I'm going to compare that to the human skeleton over here. So, we've got all these structural members of the human skeleton, like the cranium and the scapula and the pelvis and the femur and the fibula, tibula, right? So all those structural members hold up us, right? But you can see there's lots of empty space, but there's parts and pieces that go in that empty space. Okay. Same thing with residential framing. We've got the names of the parts and pieces. For a carpenter, we need to know the names of those parts and pieces. If we're a doctor, we need to know the names of those bones in our body. Those studs, joists, rafters, and girders that make up the frame, they're made out of wood. Right? Most of the time, especially around here, we use wood frame construction. Why? Well, probably the number one reason why is because it's cheaper. It's economical. We've got lots of trees around. Trees grow for free. We can just cut the trees down, take them to a sawmill, slice them up, make lumber out of it, and then bring it to a job site and assemble all the little pieces to make our house. Um, and wood, right? Wood is really durable. As long as you keep it dry, as long as it doesn't get wet, it'll last for a really, really long time. It can provide good insulation, but there's probably one drawback, one disadvantage if you're thinking about wood right now is that it burns. So that's a major problem that we have to deal with. Before we get there, I'm going to say that residential houses, structures, right? The overall length and width of the house is usually evenly divided by 4 inches. And so this is what we call modular design. And if we use modular design, you'll see that we'll waste a lot less material. We won't have to cut. In this situation here, we have concrete blocks, right? The blocks are 16 inches long. And if it's evenly divisible by 4, it works out that we don't need to cut a block in half. Okay, so we're going to save money by not taking the time to cut a concrete block in half because it takes some time to actually do that. Plus, a lot of times, what do you do with the extra half of that block? You throw it out, right? So we use modular design, and if it's evenly divisible by 4 inches, it's modular design, and it should save us time and money. We are talking about wood being such a great building product. Another disadvantage of wood is that it can shrink. This is a board or a piece of lumber. It does not shrink over its length. Okay, 0% shrinkage over its length. Its thickness and its width can shrink. When it dries out, it shrinks. So we got to make sure, first of all, when we build our building, that it's already dried out. And even then, it's still going to dry out a little more. So we have to take into account, we have to think about what happens when this board over time just gets a little bit smaller. What's that going to do to our house? This is what we call stick frame construction. Okay, so each board, each piece of lumber here, I could pick one of these pieces of lumber up, I could put it in place, and I could nail it. So it would take a really, really long time, but probably me and I would probably need at least one helper. I could build this, with a hammer and a saw. All right. So, and you can see it's a frame. There's lots of empty space around that we'll use for other things. I just want to talk about two by lumber, right? All these pieces are 2 by lumber. It's either 2x4, 2x6, 2x8, 2x10, 2x12. You get the idea. It's all 2 inches by something else. Here's a log frame. So log frame, the wall is pretty much solid. It's full of wood here, right? So first of all, log frame is going to use more wood. So it's got to be more expensive, right? Plus log frame. These things are big and they're heavy. I could not lift up one of these logs by myself. I could, probably two people couldn't do it. You'd need a whole bunch of people or a crane. Um, I couldn't cut one of these pieces by myself. We have no tools in the shop that would cut through a log like that. Right. And then also talk about shrinkage. Remember, we said over the width of the board can shrink 8%. What happens if all these boards just shrink a little bit? The whole house is going to, the whole wall is going to shrink a little bit. And that could cause a problem with maybe windows and doors. They won't open and close properly. So we know that log houses are cool. I love to live in a log house. We also know that they could potentially be more energy efficient than stick frame because wood is a good thermal insulator. However, we know how to insulate really well in a stick frame house. So we got some advantages and disadvantages of that log frame house. This is what we call post and beam, otherwise known as a timber frame. Again, we got big, heavy pieces of not lumber, but timber. This is the post. This is a beam. This is a brace. Again, going to need a crane to pick this up, or lots and lots of people, and you need specialized tools to work with this. The post and beam, these things are almost too big. You can't nail them together. You might be able to put spike them together. But how they put them together is with a mortise and tenon. So maybe look at this picture here. This really is a square hole. And then what we have is kind of a rectangular peg. And the rectangular peg goes in the square hole. And then what they do is they drive a pin through it. So that's kind of your typical construction technique for post and beam houses, is what they call mortise and tenon. The post and beam house is insulated from the outside. So if we go back here, we want to see all that nice woodwork on the inside. So we don't want to fill up this area with insulation. We want to be able to see those timbers. So what they do is they use these super insulated structural panels here on the outside, on top of the roof, on the outside of the wall. It's good for insulation value. However, right, this stuff here, super flammable. Not only is wood flammable, if we put a match to this piece of plywood here, this OSB, it would take a little while for that thing to catch on fire, but this would just take a couple seconds and the whole thing would be on fire. So things to think about. Now, this is an example of balloon framing. Now, this is something that's not done anymore. This was done up until probably pre-World War II. However, it always happens. Think about the houses in our area that were built before World War II. Those are probably in the city of Albany and Schenectady. Colony really took off after World War II. So we don't have a lot of houses in Colony that are balloon framed. However, you'll see it on the news sometime if there's a fire in an older house. The next day in the TV news, the fire chief will say, "Oh, it was a really difficult fire to fight because it's a balloon frame structure," and he's right. So back in the day, this right here is a stud. Okay, so this stud went from the top of the foundation, went all the way up to the roof. And think about this. Think about if you had a little electrical box down here buried in the wall, your electrical outlet, and there was a spark. And what happens is the spark causes a fire. You have a fire right here. Well, look, there's nothing stopping the fire from going from the first floor. It's going to go right past the second floor and then right up into the roof. It's got to burn through this board here, but it's got this chimney. It's got a direct pathway right to the roof. So another problem with this type of framing was you need a really long lumber. Okay, so this is probably at least 18 feet long here. And this might be getting a little heavy. I might not be able to pick that up by myself. Okay, so talking about fire, inside the wall. So this is a wall. These are studs. This is how walls are constructed. There's studs, and this material here is drywall or sheetrock or gypsum board. There's a bunch of names for it. But again, think about this. What if there was a little spark, maybe in the electrical box that would be down located here? Okay, we don't want the flame traveling very far, so we do this. We put just a chunk of wood in here. It's called a fire block. That will block the flames from reaching too high up here. It's going to take a while for it to burn through that 2x4, maybe 20 minutes or so. By that time, hopefully you smell smoke. Hopefully everybody got out of the house, and hopefully the firemen are there and ready to put this thing out. Anytime you have a hole going through the wall or the floor, here we have some kind of, looks like a dryer vent or something like that. It's poking through the wall. You have to caulk up. You have to seal that penetration there so that no fire could sneak by there. Same way if you have a pipe going from one floor to the other floor, you have to make sure that the fire stays contained in one area. If we were in the wood shop right now, I'd tell you to go look in the wood storage room and look up at the ceiling, and you'll see where the floor or the wall meets the ceiling. You'll see this pink caulk to keep the flames from jumping outside of the walls if there was a fire in the wood shop. And there was a fire in the wood shop 25 years ago. I've got the pictures for it in the shop. The whole thing burnt right down. There was nothing left salvageable in the shop. However, out in the hallway, there was no fire out in the hallway. There's no fire in the art rooms. The fire was contained to the wood shop because of things like this. So today we do something called platform framing. So what's going to happen? We build a concrete foundation. The next thing we build is this floor right here. The first thing we do is we build the floor. We have a nice big flat area. And then what we can do is we can build the wall. This wall would be built laying down on top of the floor. Okay, so we got a nice big area. It's flat. And then what we do is we just pick that thing up and roll it up into position. And this is what they call platform framing. Once you have all four walls built around the house, then you could, if you wanted a two-story house, you could build another platform up top, another big flat area. Then you could climb up there and you could build more walls and you could put more walls up. So this is what we do today, platform frame construction. Here is a picture of a balloon frame compared to a platform frame. So if you look real close, you can say, oh, they're the same. So we have to look even closer to figure out what the difference is. You should be able to identify the difference, be able to tell me which one's balloon frame, which one's platform frame. So you can see here, we've got our concrete foundation, and here the floor comes next, right? On top of the concrete foundation is the floor. Over here on top of the concrete foundation is one of these studs that go from the foundation all the way up almost to the roof, where here the stud only goes from the top of the first floor to the bottom of the second floor. The floor. So we're going to need to know, to start with, the structural names of the parts and pieces, the main parts and pieces that make up a house. So the first thing I'm going to tell you is this thing right here, the girder. Okay, this is a girder, which is a beam. Okay, beams are horizontal. Okay, they run horizontal. The main structure, the main part of a floor is called a joist. So this here is a joist, and this is not an accurate picture of a joist. Okay, the span is from one side of the house to the other side of the house. That's the span. Now I know you can't buy lumber that would go from one side to the other side. Okay, it'd be special order stuff. So what happens? We kind of cut this. These boards are half as long as they appear here. And so what we need is we need something to hold up the ends of the board in the middle of the house, and that's what the girder does. So the girder is held up by the concrete foundation and by these columns. And then the floor joist rests on the girder and on the concrete wall. So far, we've got girder as a horizontal structural member. It's a beam. The joist is the main horizontal structural member of the floor. Now, the floor, even though you think that the piece of wood is really strong and stiff, if you have a 12-foot board, it's actually pretty easy to bend. So we don't want the boards to be bending. So what we do is we put this, what we call bridging in. And here's another picture of that girder we were talking about. The girder is notched into the concrete and it's flush with what we call the sill plate. And so what we have a concrete foundation, and then we move to we start to use wood here. So the connection between the concrete and the wood is a bolted or a threaded connection. And then once we have wood, then we can use nails for the rest of the house. Wood to wood, we can use nails. That's another picture of the floor girder, the beam that's holding up the floor joist. Then we've got walls, right? So first of all, these walls on the outside of the house, yes, they're called walls. The things on the inside of the house that we call walls aren't really walls. They're supposed to be called partitions. So we've got walls on the outside, partitions on the inside. Then on the outside, we have what we call load-bearing walls. Okay, so there's going to be a lot of weight sitting up on top of this wall right here. So you can see over the window and the doors that we have these big chunks of headers to hold up the weight over top of the windows. So this is what we call a load-bearing wall. Over here, there's not a lot of weight pushing down on this top of this wall. So you can see there is no header here. So this is what we call non-load-bearing wall. So we've got load-bearing walls, we've got load-bearing partitions, and we have non-load-bearing walls and non-load-bearing partitions. So this is a picture of the wall, and kind of going back to our picture of our skeleton, there's lots of different names of all the parts and pieces. The one thing that we need to know right now is the name stud. Okay, the main structural component right here, this board is a stud. And this board right here is a stud. And this board right here is a stud. They call them OC studs, on center. It means from the center of this stud to the center of this stud is going to be 16 inches. And then from the center of this stud to the center of this stud is going to be 16 inches. And that kind of goes back to our modular construction. So now we know girders, we know joists, we know studs. Now the roof. There's two different ways we can put the roof up. We can use trusses. This is an engineered structure that's built at a truss shop or truss factory. It comes on a big truck. You lift it up, probably with a crane most of the time. You get that in position, and pretty quickly you can build the roof of the house. And it has smaller lumber too. These are sometimes 2x4s or 2x6s. So they're actually quite light compared to doing it with rafters. Another way of building the roof is with a rafter. So this is a diagonal, a structural member that's on a diagonal, and it holds up, it makes up the roof. All right. And so what happens, you just put one up at a time. Right. So I could take that rafter, I could cut it, I could lift it up there by myself, hold it up somehow and nail it in position. So that is one way of building the roof, is with rafters, or we could use a truss. And we talked about fire with houses, but we also talked about insulation, keeping your house warm. All right. And so with trusses and even walls, in the empty spaces, what we do is we put fiberglass insulation. Okay. The pink Owens Corning Pink Panther fiberglass insulation, that big blanket. And this is a picture of a truss. Notice this area right here compared to this area right here. This area, this is where we're going to put our insulation. Okay, but here there is no space for the insulation. So we'll have a well insulated floor, but then we get down near the outside edges here and there's going to be no insulation. So this is just a different type of truss. It's called a raised heel truss for better insulation in your roof. All right, so to wrap it up, we know a little bit about the different types of houses. We've got stick frame. In the stick frame category, we've got balloon frame and platform frame. And then there was things called log frame or timber frame. And then we know the main parts, right? It starts with the concrete foundation. We have a girder. Then we have a joist hold that makes up the floor. Then on top of the floor, we have a wall. And the main part of the wall is a stud. And then when we get to the roof, we can either frame it with a truss or we can stick frame it with rafters. All right, here we go on our adventure to building a house.